All right, guys, so just got to do this one problem and we'll be on our way. Consider the quadratic function x squared, f of x equals x squared minus 4x minus 36. Bless you. It says algebraically determine the function's x-intercepts, right? Using the quadratic formula. So what we're going to do is anytime we want to find x-intercepts, we're just going to take that function and set it equal to 0, right? And what is that going to do? That's going to give me my a, b, and c terms. And what are we going to do with our calculator? We're going to store them all in, right? And then we're going to evaluate each of these expressions. And I think you guys practiced that quite a bit yesterday. So go ahead and get those three expressions on your calculator. All right, so what do you guys got for a negative b? 4? Okay, how about 4b squared minus 4ac? Say again?
Negative 1.8. I don't know where I get them.
What did you store in? Did you store in for c? Did you store in negative 36?
Oh,
that may have been the problem. Yep. So again, I mean, the devil's in the details, right? You make one mistake and the whole thing's blown, right? So 160, right? And the 2a is going to be 2, right? And so we have our three pieces, and we plug them into our three positions in our formula. Now, guys, if this were a part 2 and the question said express your answers in simplest radical form, this would not get you full credit, right? Because we can break down the radical 160. What's a perfect square that goes into 160? An easy one. 16 goes into it how many times? 10 times. So like that. What is the square root of 16? 4. Like this. But I still have one more thing I can do, because what does 4 radical 10, and 2, they all have a divisor of 2, right? So my final answer would be 2 plus or minus 2 radical 10. Are we okay with that? Now, guys, the next piece of this says to express these answers to the nearest hundredth, right? Well, what does that mean? I want decimals now, right? So I'm going to go to my calculator, and I'm going to do 2 plus 2 radical 10. 2 minus 2 radical 10. And those are my two answers in terms of x solutions that I can round, right? What would be the first one if I were to round it to the nearest hundredth? 8.32, right? Because this 4 is less than 5, so I leave the 2 alone, right? And then this is going to be what? Negative 4.32. So I have 8.32 and negative 4.32. Guys, we're sitting at a Regents exam, let's say, okay? And this is a question that I'm solving. I want to be really sure that I did it right. This was my last answer, right? Is it possible I could have made a mistake from here to here? In which case, I've now made 2 mistakes, right? So give me a couple of ways that I can determine if I did it right. Give me something I can do. Well, what if I put this in the calculator, right? If I did it right, then I should get the same answer for this and this, right? So this would be one thing I could do. So I could create my fraction and do 4 plus radical 160 over 2. And so these are the same, so I feel pretty good about that, right? But what if I made a mistake doing this? Then what? I could go to, where do you want to go? You want to go to this and do what with it? Polyroot it, right? Polyroot it. So again, menu, algebra, polyroot it. So what were the numbers? Negative 4 and negative 36. And there's my answers again, right? So, this is one of those cases, guys, where finding roots, or finding solutions to a quadratic, where before you had to rely on being able to factor correctly. Now it doesn't matter if you can factor correctly in terms of getting the solutions. No, right? You should be able to get the solutions either using this or using the quadratic formula. With me? All right, so guys, on my graph, these two things go on my x-axis, right? So I have negative 4.32 and I have 8.32. So I got my 2 points. Guys, give me another point on this parabola that I know. Negative 36. Where does it go? What is this? What is this on the y-axis? That's the y-intercept, right? That number at the end is always your y-intercept. So negative 36 is another point. And this just said to what? Sketch a graph. Use the 0 function. We don't really need that. We have our 2 points, and we can just create our sketch. And there it is. Guys, what is this idea about the 0 function? What does that mean? What does that mean? So I got this, right? How come I don't see the bottom? What's the issue here? My window, right? Do I see the x values that I want in terms of the roots? So what can I do to see the bottom? Do a zoom fit. Yeah, zoom fit. The x values won't change, but the y values will fit the graph. So now I can see the bottom. That's cool, right? And the idea of that 0 function, guys, is where you go to analyze graph. 0 means find the roots, right? And this is where I put the little little vertical line to the left, and I create that shaded region, and it gives me the root. And then I find this one, I got to move it over a little bit. And it gives me the other root, right? So now what have I done, guys? I've shown you literally, if you think about it, I've shown you about 5 different ways that you can get roots to quadratics. You can factor, yes? You can complete the square. You can use the quadratic formula. You can use polyroots. You can graph it and find the zeros this way, right? So you have a multitude of ways to get roots to a quadratic, right? And ultimately, roots are the same as finding solutions, right? Well, finding roots, finding solutions, whatever it is that you're trying to do to solve for a quadratic, you have many ways to do it now, okay? So when you see a question like this, which of the following represents the x-intercepts, another word for zeros, another word for roots, another word for solutions, right, of this quadratic, okay? So I like to go from easiest method to hardest method, right? What would be the easiest way to get the roots? Okay, so, but graphing requires me to type it in. Yeah, polyroots is the easiest way, right? Polyroots is by far the easiest way to do it. So let's go ahead and polyroot it. So I have a 3 and a -19 and a 6. Intriguing, right? And again, guys, I mean, yeah, could I have tried to factor it? Sure. Yeah. Could I have tried to graph it? Yeah, sure. Could I have quadratic formed it? Yeah, sure. But again, on a part 1 question, and this is an example of what an Algebra 2 part 1 question could look like, okay? And we go right to the answer. Cool? Cool.